Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the Cannizzaro reaction, the specific fate of aldehydes that have no alpha hydrogen to spare. Let's begin. The Cannizzaro reaction is genuinely specific to aldehydes that have no alpha hydrogen available, meaning there's no hydrogen atom on the carbon directly next to the carbonyl group, and therefore these aldehydes are completely incapable of undergoing aldol condensation. Classic genuine examples include formaldehyde, benzaldehyde, and other aromatic or fully substituted aldehydes where the carbon next to the carbonyl either doesn't exist, as in formaldehyde, or bears no hydrogen atoms, as in benzaldehyde's aromatic ring carbon. When such an aldehyde is treated with a concentrated strong base, like concentrated sodium hydroxide, it undergoes a genuinely different pathway, entirely a self-oxidation reduction, or disproportionation reaction between two molecules of the exact same aldehyde. In the Cannizzaro reaction, two molecules of the same aldehyde genuinely react with each other in the presence of concentrated base. One molecule is oxidized to a carboxylate salt, while the other molecule is simultaneously reduced to a primary alcohol. This is exactly why it's called a disproportionation, or self-oxidation reduction, reaction, since the same starting material genuinely ends up in two different oxidation states. Mechanistically, hydroxide ion attacks the carbonyl carbon of one aldehyde molecule, forming a tetrahedral intermediate. This intermediate then transfers a hydride ion H- directly to the carbonyl carbon or second aldehyde molecule, reducing it to an alkoxide, which then picks up a proton to form the alcohol, while the first molecule, having lost that hydride, becomes the carboxylic acid, which is immediately deprotonated by the excess base into its carboxylate salt. For benzaldehyde specifically, this produces sodium benzoate and benzyl alcohol in a 1:1 ratio. The single most important first check on any JEE question involving an aldehyde and strong base is genuinely identifying whether that aldehyde has an alpha hydrogen. If yes, expect aldol condensation. If no, expect the Cannizzaro reaction instead. This alpha hydrogen test is exactly the deciding factor examiners test again and again. A frequently tested extension is the Cannizzaro reaction, where formaldehyde is genuinely deliberately mixed with a different aldehyde lacking alpha hydrogens like benzaldehyde. Since formaldehyde is a genuinely much better hydride donor than benzaldehyde, formaldehyde preferentially gets oxidized to sodium formate, while the other aldehyde gets preferentially reduced to its corresponding alcohol. This selectivity makes crossed Cannizzaro reactions genuinely useful and predictable in synthesis. Also remember, the reaction requires concentrated base, specifically dilute base instead favors a completely different, unrelated reaction pathway for these substrates. Let's recap. The Cannizzaro reaction happens specifically to aldehydes with no alpha hydrogen, like formaldehyde and benzaldehyde. When treated with concentrated base, two molecules disproportionate, one is oxidized to a carboxylate salt, the other is reduced to a primary alcohol via a hydride transfer mechanism. In crossed Cannizzaro reactions, formaldehyde is preferentially oxidized since it's the better hydride donor, and the key exam check remains simple: no alpha hydrogen means Cannizzaro, not aldol condensation. That's the Cannizzaro reaction. Keep the no alpha hydrogen test and the disproportionation mechanism sharp. They're exactly what separates this reaction from aldol condensation on the exam. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.